Hi, everyone. My name is Diane Coe. I use pronouns she, her, and I'm also known as @BackwardOK on various social channels. Hopefully you're enjoying the talk so far and are now super excited to hear from me today about supporting accessibility in React, the difficulties and niceties. But first, who am I? I've been working in the front-end space for a while now and joined the accessibility team at Etsy last year. Today, I'm wearing one of my older AxCon shirts, which I have to kind of step up a little bit for you to see, that says digital equality is my jam. I don't identify as disabled, but I've been passionate about accessibility for the last 10 years or so, ever since I was first introduced to it. Some of you may also be able to see some of my other passions behind me, including some Beatles posters to my right, some ski bags behind me, and some hockey sticks. I'm also a human companion for two rabbits, Buttons and Bandit, who will make some cameos today. Buttons is an all-black rabbit and is pictured here with her tongue sticking out. And Bandit is a smaller gray rabbit with white fur on his front paws, and he's pictured here lying down with his little paws sticking out. So we'll say goodbye to my bunnies for now and get into our topic of supporting accessibility in React. But why are we talking about React specifically? For those of you who are less familiar with React, React is a JavaScript library that allows you to build UI components using HTML and JavaScript in a more seamless way. We're at a point now where React has become an incredibly popular way of building interactive websites. So much so that in the last State of JavaScript survey, 2/3 of respondents indicated that they've used React before and would use it again. And one of those 2/3 of respondents was me. I've been using React for the last 7 years and have gotten used to some of the ins and outs of doing things in React. One of the questions I've seen more than a few times is if React makes accessibility easier or harder. The short answer is an inclusive yes. Okay, so cool. Talk's all done. We can take a break now, right? Just kidding. So today I'm going to walk through three common use cases you've probably come across before that demonstrate some of the ways that React makes building in accessibility easier or harder, and how to take advantage of or work around those aspects. I'll be introducing React concepts as I go for those who are less familiar. We'll start off on some of the simpler concepts before getting into some of the more intermediate and advanced concepts. Also, disclaimer, none of the code I'm sharing is production-ready code. In many cases, I'm sort of hand-waving some of the details and omitting some of the aspects that would probably be included for the full experience. So that way we can focus on the areas that are the most relevant. All right, so let's start with a pretty common feature, a sign-up form. Pretty much every site that you have an account with has some kind of sign-up form. Getting the accessibility right on something that's so crucial for using a site is incredibly important. Just yesterday, there was a whole talk on form accessibility alone. So let's talk about aspects of React that can tie into accessible form building. For my example, I'm using a fairly simple sign-up form. I have 2 text input fields for a username and an email address. Below that, I have a sign-up button. In this design, the 2 input components have an identical appearance. If I built this form in pure HTML, I would need to essentially duplicate the HTML for these 2 inputs. I would have a form as the outer wrapper that contains 2 label elements and a button. Inside each label element are a div and an input. This doesn't include any styling applied or any other attribute I may want. If I ever wanted to change the way the component looked or behaved in the future, I'd need to make sure I updated every single instance of similar input that exists, or just deal with the site being inconsistent. This is where using components can be really impactful. Instead of duplicating HTML, we can create a component that represents the input field and use that in multiple places. Now, creating components isn't unique to React, but It's one of the primary aspects of using React, especially when compared with using vanilla JavaScript and HTML. So, to create a React component, we can create a function that takes in a set of properties that are passed in by the consumer called props and return HTML to render for the component. By the way, throughout this talk, I'll refer to someone who uses a component in code as a consumer to disambiguate them from an end user, which is someone who would use the resulting site or interface. Okay, so for our input and label combination, let's create a new component called input field. The overall HTML structure I'm going to create is a label element, wrapping a div element, and an input element. Now we need to think about what props we need when we're rendering our component. For now, we mainly need to handle the label text, since that's the visually different thing for the inputs. Each prop is defined as a key value pair in the props object. We can destructure the props object to define what props we expect. In our case, let's define a prop called label text to represent the label for the input. Then we can take that property and set it as the inner content of the div element. So when we go back to our signup form design, we can create a new component called signup form that returns the basic form HTML that we wrote earlier. And then we can replace the label, div, and input element sets with our new component, input field. We can also set the label text prop on the input field components with the labels for the field in a similar way that we would set an HTML attribute on an HTML element, passing username for the first component and email address for the second. This brings us to our first nicety, component reusability. This is especially useful for a component library where you can define a set of shared components that get used across the site. I can create a semantic structure for my component and have all instances of its usage take advantage of the semantics to better support accessibility. Additionally, if there's an issue with the component, I can fix it in one place rather than all the different places it shows up. This can make it a lot easier to scale accessibility fixes. Defining specific structures in reusable components is also useful for things like field sets or lists, where the element hierarchy needs to be defined in a certain way to work properly. All right, so now that we have at least a form that can render, and it's using semantic HTML, and we're adding in labels, but we haven't specified how label text should be used. Right now, nothing is stopping someone from using our new input field component without label text. Or someone could pass in a JavaScript object and we'd get one of those bracket object labels. It might be useful to declare some information about our prop so that component consumers can use the component in the way we intended. React has a built-in way to handle prop type checking using prop types. Prop types allows you to explicitly define what kinds of props are allowed, what type of element those props should be, and which props are required. If you use TypeScript, you can define the types for your props using TypeScript types instead of React prop types. For today, I'm going to stick to React without TypeScript for simplicity. So let's go back to our input field component so we can add type checking for our props. I want the label text prop to be required since all inputs should have a visible label for better accessibility. And for simplicity, let's only let people pass in string values for the label text prop so that we can semi-guarantee that it's at least a valid thing to render as a label. To use prop types, we set a prop types property for our input field component to an object that contains the prop definitions. I'm going to define the label text prop as proptypes.string.isRequired to indicate that this property is of type string and it's a required property for this component. This makes it so that if a consumer were to try to use our input field component without label text, or a value that's a string, it would throw an error. This is another one of React's niceties, prop enforcement. Declaring certain props as required and what type they are with prop types provides a way to enforce how a consumer is using your component and enforce specific accessibility requirements. This can also be really powerful for things like enforcing that alt text is set for an image, or enforcing that ARIA attributes are set to valid values. If I can encourage accessibility in some way without even being there, I consider that a win. All right, so going back to our form, we now have much better accessibility built into it in the neutral state. But what happens if there's an error? Let's say someone picked a username that was already in use when they signed up. We want to include an error message for the username field and move focus to it. Let's start with the error message case first and go back to our input field code. In our new design for error handling, we now have an optional error message that will appear below the input with a warning emoji. What we want the component consumer to pass in now includes label text and optional error text. Let's add an error text prop as a possible prop someone would pass in. For the error message, we can conditionally render it by checking the truthiness of the error text prop and use a double ampersand with the HTML for a div containing the warning emoji and the error text content. This provides a really nice benefit of automatically rendering the error message the way that we want it when error text is passed in. For this example, I've put the error message inside the label element, which adds the error message as part of the accessible name for the element. Additionally, we may want to indicate that the input is invalid when error text is passed in. To do this, I can conditionally set the ARIA invalid attribute to true when error text is present. Otherwise, return undefined. Setting the attribute to undefined rather than false will result in the attribute not rendering on the element when it's not needed. This brings us to another nicety, using logic within HTML. Using JavaScript logic in our HTML lets us conditionally render different elements and attributes, which makes accessibility easier for the component consumer. Now, this component is doing a lot of extra work for the consumer with a single piece of information. This is especially useful for more complex ARIA patterns like tab panels or combo boxes, where abstracting away the complexity to the component consumer can result in less room for error. All right, let's go back to our signup form again. You might be thinking, hey, you've only mentioned nice things so far. When are you going to mention a difficulty? Well, don't worry, one is coming. I mentioned earlier that we'd also want to move focus to the field in error. The problem is, at the form component level, I no longer have an input element that I can directly focus. The input element is abstracted away with our input field component. This brings us to our first difficulty, accessing DOM elements of other components. If we want to follow the React philosophy, React components shouldn't be aware of how other React components are implemented because that breaks the abstraction. And it could also change at any time without the consumer knowing. This makes focus handling particularly difficult in React, which is critical to handle well for accessibility. There are a few ways to solve for this. I'll walk through one way and talk through additional options later. So let's go back to our input without some of the implementation details available, where we have a label element, wrapping a div, and an input. React has a way to store a reference to a value called useRef. One of the primary uses of it is to store a reference to a DOM element. We can do this by creating a variable, let's call it inputRef, and set it to the result of calling useRef with an initial value of null. React provides a ref property that can be set on a particular component or node. For our component, we set the ref prop of the input element to the input ref variable that we made earlier. But this only makes the ref available to the input field component. We want the ref to the DOM node available to its parent component. So to do this, we need to forward the ref so that it's available to use by its parent. React provides a forward ref API to expose a ref to the component consumer. Instead of defining a functional component that only takes in props, the component now takes in both props and a ref as its arguments. In code, we can change the way we declare our input field functional component to use react.forwardRef. Then, instead of setting the ref prop on the input to the input ref variable that we had earlier, we can set it to the passed-in ref argument. Now I can get a ref to the input from the signup form component. So going back to our signup form, we can now do a similar approach to getting a ref using the useRef call. We'll create a new variable called ref and pass that variable to the username input field component. Now that the signup form component has a ref to the username input DOM element, we can handle the error case on submission. The DOM element will be available by accessing ref.current. We can create a handle submit callback function and pass that function to the form element as the onSubmit prop. In the function, we can now check if there's a username error and then call ref.current.focus. This approach works for simpler cases where you only have to go one level deep to access a DOM element, but that may not always be the case for what you need to do. I want to mention a few other ways to handle focus that you can use, although I won't go into their implementation details. Another approach is to let the component handle any DOM operations itself. This bypasses the need for a parent component to access a child component's DOM elements. This can be a little tricky since the component needs to make sure that any side effects, like focusing, aren't going to trigger on every render. In this approach, you can use a useEffect hook to trigger side effects on mount or based on a passed-in prop. This can be useful for things like focusing new page content with dynamic routing on content load. Another approach is to bypass React conventions and use a DOM query, like getElementById, to target a specific element. This breaks from the React philosophy, but it may be useful in cases where you may not be able to access an element otherwise. All of that for a basic signup form. Even Bandit here is exhausted, flopped over on his side with his feet floating in the air. Hopefully, unlike Bandit, you're all still here with me and ready for more, because it's time for another common scenario. Let's talk about cards. Cards often consist of an image on top and some content below it. They're often used as a more visually appealing link. Cards have become incredibly common on websites, especially for e-commerce sites and blogs. In my example, I have a picture of Bandit sitting with his paws tucked underneath him, and then underneath that image is larger text that says Bandit, followed by smaller text that says breed, rabbit, cost, priceless. So creating this in pure HTML, I'm creating a wrapped div that contains an image element, an anchor that wraps an H2 for the card title, and a P tag for the card description. To provide extra context, I'll use role equals group on the containing div and set aria labeled by to the ID of the H2. Then, to provide extra context to the link, I'll add aria described by to the link and set it to the ID of the P tag. When turning this into a React component, I'll want to avoid having all cards set with the same ID, so I know that I'll need a unique ID for the title and a unique ID for that description. So turning this into a React component I now have code for a card component that takes in a title ID prop and a desk ID prop, short for description ID, which I didn't feel like writing out. Those props are then used for the IDs of the H2 and P tags, as well as for the ARIA labeled by and ARIA described by attributes for the div and link. But now the consumer needs to pass in two different IDs. What might be simpler is having the consumer only pass in one. I'm a big fan of trying to reduce friction for consumers and reduce potential room for error. Since we know where these IDs are being set and used, we could generate these IDs based off of a single passed-in value. So we can update the code that instead of passing in title ID and desk ID, the consumer passes in ID. We can then use string templates to generate IDs for the title and description. For this code, I'm setting a title ID variable with a string that prepends card-title- before the ID value. Similarly, for desk ID, we're prepending card-description-. Now, the consumer doesn't need to do as much work to pass in an ID, and we can make the ARIA associations for them. You could even go one step further to reduce friction and have the ID attribute as optional and dynamically generate an ID using React's built-in useID hook that was added in React 18. This gives flexibility to consumers that want to control the ID, for example, when running tests, while also providing an option to more confidently ensure that there's an ID set and that it's unique. In the code, I've now created a new variable called generated ID that's set to the return value of the useID call. I then can create a variable called uid that uses a ternary to set it to the passed-in ID value if it's present, otherwise uses the generated ID value. The useID call needs to happen in its own line because it's a React hook, and it can't exist within any conditional statements or loops. This brings us to another nicety, ID generation. This lets us more easily match associations and also makes it easier to guarantee that the ID attribute values stay in sync, which is critical for the ARIA associations to work. And by generating ID values, whether from a hook or from a passed-in value, we can also make it easier for component consumers to use our component. All right, let's go back to a simplified version of our code without the attributes set. In this code, we have an H2 for the heading. But what happens if the card is used in a place where it should be an H3? This brings us to another difficulty, knowing where a component might be used. We don't have a lot of control over where our card component will be used or what level it will be nested in. For components that include heading elements, this could result in a number of page hierarchy issues where the heading levels don't seem to make sense. One way to solve this is with the React Context API. So let's create a new component called heading, and it takes children as a prop. Children is a reserved prop name for the content that was passed in inside of the component tags when it was used. We know we want to have some kind of heading level context that's defined somewhere. So let's assume we'll call that context level context, and it will return the level that we need for our heading component. Then we set a variable, h, to be a string that concatenates h with the level so that the resulting h variable will be h1 when the level is 1 and h3 when the level is 3. Then we can use the h variable as the element name that wraps the passed-in children. As it turns out, we came across another nicety while we were solving one of our difficulties, variable elements. With React, you can use a string value that matches an HTML element name and use the variable name as an element. Variable elements are really powerful for any sort of element that you may want to adjust dynamically depending on some factor. For example, and this may be contentious, if you had a component that looked the same when it was a link or it was a button, you could conditionally render an anchor when an href is passed in and a button otherwise. I'm not saying you should do that, but chances are you've probably come across something like that. So we might as well make the semantics appropriate. Note that this approach might be kind of a pain if you're using TypeScript, because you might lose some of the built-in type checking for valid props set on the variable element. In that case, you may opt to use a switch statement to check every level value and render the appropriate heading level accordingly. All right, so let's go back to solving our difficulty. With headings, we want some kind of way to create page hierarchy, and it would be great to be able to dynamically increase the heading level when we nest further. So let's create our context by creating a new variable called level context and set it to the value of calling create context with 0 as the initial level value. Then we can create a section component which takes in children as a prop. We want to be able to dynamically update the level as we nest further. So we'll grab the level from level context with a use context call. In the HTML we return, we'll create a wrapping section tag that includes our content provider, which we include as level context.provider. We also set what level we want the provider to share with its children. Since we want the auto increasing levels, we'll set the value to level +1. Then we pass the children into the provider so that all the children have access to the value in level context. So if we have several cards displayed together, like the cards that I have here with 4 photos of my bunnies in various states of standing or sitting, I can create a new component called card grid that can showcase the cards that I have. And since all 4 of the card components are nested inside of the same section component, they will all have the same heading level. Now we have components that can render anywhere on the page and automatically get the right heading level based on the level of nesting, which is a great win for accessibility. But one thing I will mention to watch out for with this approach is that if one part of the page doesn't make use of our new section component, the levels could be off. So one way around that could be allowing the section component to take in a starting level prop so that you could reset the context value for that section. This gives you a little bit of an escape hatch, especially if you don't control some portion of the page. All right, we've been talking about very specific component use cases, but our next topic is a little bit more meta. We're going to go down a small rabbit hole, like buttons here, with our head half sticking out of a hole in a cardboard box. Our next scenario is building a design system. A few areas earlier that can be beneficial in a design system, like prop enforcement and component reusability. So for this section, I'm going to primarily focus on one additional difficulty area. Creating something like a button in a design system is deceptively complex. When building a design system, it's important to be able to support various use cases while also avoiding the potential for someone to use your component in a way that you don't want. One of the philosophical decisions that you'll need to make is whether you opt to have strict props or loose props. With strict props, you're defining what props are allowed and only applying those explicitly named props to your component. So in my example, I've created a button component that uses strict props by allowing the React children prop and a type prop, returning a button element with its type attribute set to the type prop and its inner content set to the children prop. With loose props, you might define a set of props that you're expecting, but otherwise you let the consumer pass in whatever props they want to add to your component. So for this one, I've created an example button component that uses props by taking in defined React children and using the spread syntax to group all other props passed in as an other props object. Then, in the returned HTML, I'm spreading the other props object onto the button element so that it passes through all the additional props that were set. Here, I need to separate children out from the other props so that it doesn't get spread onto the button element, and so that I can set it to the inner content of the button element with the children prop. This brings us to one of the difficulties, deciding between strict or loose prop definitions. Taking the strict route lets you have full control over how the component is used. This prevents consumers from setting props that they shouldn't be set from an accessibility standpoint. For example, setting ARIA modal on a button. However, it also means that your prop definition list could get painstakingly long and unhelpful as you define all the possible props that someone could set that would be valid use cases. Taking the loose route gives us a lot more flexibility over how the component is used. This lets consumers set whatever props they think they may need without needing to explicitly define every single possible prop. However, it also means that consumers can pass in props that they shouldn't be using, including misspellings of ARIA props or invalid props. My personal preference is to use loose prop definitions, but use tooling to help prevent potential accessibility issues. So one way to avoid issues like attribute misspellings or applying attributes incorrectly is with using a code linter. The one recommended by React is ESLint plugin JSX A11Y, which is an accessibility-specific ESLint plugin that analyzes code usage and flags potential accessibility issues. This plugin includes a number of different rules that cover things like ARIA prop validation, keyboard shortcut for elements with interaction event listeners, labeling form fields, and many others. In this example, I have a button component being used with ARIA labeled by misspelled with a single L. The linter highlights the invalid ARIA attribute and includes a message. ARIA labeled by with one L. This attribute is an invalid ARIA attribute. Did you mean to use ARIA labeled by with two L's? One of the nice things about using a code linter is that it can run in your code editor, so issues are flagged immediately upon typing a code issue. Additionally, it can be run as a continuous integration check when merging in code, which can then block changes from going in that introduce accessibility issues. All right, hopefully you understand more about React and accessibility after all this and can now relax a little bit like Buttons here, lying in a sunny spot on a blanket with her eyes half closed. So let's recap some of the difficulties and niceties. Starting with the niceties. First, component reusability. This can help with standardizing accessibility, including using semantic HTML and creating the desired structure, and reduce effort to fix accessibility issues. Second is prop enforcement. This allows us to require that component consumers pass in critical information for accessibility, like an input label or image alt text. Third, using logic within HTML. This lets us render certain elements or attributes conditionally, such as error messaging or the ARIA invalid attribute. Fourth, ID generation. This can be particularly helpful for setting ID-associated ARIA attributes like ARIA labeled by and ARIA described by, and keeps them in sync with their associated IDs. And fifth, variable elements. This lets us render different HTML elements dynamically, which can be useful for choosing different semantic elements based on props or context, such as heading elements. And now the difficulties. First, accessing DOM elements of other components. This can be more work to do the React way, which makes focus handling more difficult. Using React refs can help work around this. Second, knowing where a component might be used. This can be difficult in React, which makes contextual semantics, like heading hierarchy, harder to control. Using React context can help work around this. And third, deciding between strict or loose prop definitions. This can be a difficult choice when balancing between full control over how a component gets used and flexibility for different use cases. Using tooling can help with this. So let's go back to that question that I brought up at the beginning. Does React make accessibility easier or harder? There are some really great features that you can make use of in React that can make scaled accessibility easier, especially if you have a broadly adopted design system. But at the end of the day, it's another front-end framework. If you're already using another framework, the gains of using React may not offset the cost of migrating and setting everything up. All that being said, while it does have its drawbacks, I still personally find that it makes my job easier, both as a developer and as an accessibility advocate. And as a bonus, I also wanted to mention a few additional open source tools that can make it easier to avoid creating accessibility issues and some helpful resources, although this is not an exhaustive list. First, for component testing, React Testing Library encourages developers to query for elements using the by role query, where you can find components by their accessible name and role. So for example, I can render a button component with the inner text of my button. In my test, I can render the React for the button and query for the button element by calling screen.getByRole with the role name of button and an object that includes the name of my button. With that queried button, I can do other actions, such as triggering a click event on the button with user.click. Using the by role query intentionally can help reinforce having proper semantics and labels while testing components. Another one is Storybook. So Storybook is great for isolated component building, and it provides a way to work on a single component at a time and render that component in its own sandbox. There's an accessibility add-on that can be installed that adds an accessibility panel. The panel runs Axe Core on the rendered component and shows the result of the scan to users. So for example, I have a screenshot of Microsoft UI's toolkit Storybook for their button component with the accessibility panel open, showing 0 violations, 4 passes, and 0 incomplete checks. The Passes tab has 4 different accessibility checks and a way to highlight the results of those checks. Listed in the Passes section are the following rules. Buttons must have discernible text, elements must have sufficient color contrast, IDs must be unique, and ensure interactive controls are not nested. Including accessibility into tools that developers are already using to test their components, like Storybook, is a great way to consistently and constantly remind people about accessibility, which is half our job anyway, right? I also put together a list of additional resources that go over many of the React features that I went through today, including React guides on prop types, conditional rendering, using refs, using effects, using UseID, using context, and using inputs. That's it for me. Thanks everyone for being here. I'll leave you all with one last photo of my bunnies with Bandit flopped out on his side in a sunny spot next to Button's head, which is poking through a cardboard structure. Once again, I'm Diane Coe. You can reach me at @backwardok on Twitter, and I'm happy to answer some of your questions.
Yeah, super awesome. Thank you. We've had a very active group that has been discussing and asking questions along the way and answering questions along the way. So I pulled out a few of them. Let me read the first one. It's also in your Zoom chat. What are your thoughts on single page applications which have become a common use of React? SPAs have unique accessibility challenges, which unfortunately many developers who build them are quite unaware of.
Great question. So I think there's nothing inherently wrong with using a single page application. And if you are aware of how to handle focus as you move from page to page, it can make the experience pretty seamless since everything is already loaded on the page. The downside, naturally, is that you lose some of the default browser behaviors when you navigate, like having focus automatically handle itself. So it does require a lot more intentionality, and it's easier to accidentally not support accessibility as well. But if you can use it well, I think it's actually can be a really great experience.
Awesome. Thank you for that. Here's a second question. Duplicate IDs. Can you recommend some good practices how to avoid issues? Also, how to write code that is good for unit testing?
Yeah. So one of the techniques that I mentioned for ID generation was using the use ID hook, which creates a randomly created ID. One of the nice things about this is that every instance then should be unique. But then for testing purposes, if you allow an ID to still be passed in, on your test, you can set some whatever ID that you feel like so that it's not going to change every single time that you test it. And then that can be something that you can test against.
Nice. Perfect. You are jamming through these. All right. I'm going to give you a question that was already answered in case you want to add something to it. Would screen reader users find the login form error message more easily if it were placed above the input instead of below? The answer that was provided is that screen reader users find the error message based on association, not based on location, ideally.
Yeah, so this one, I think there's a lot of different ways that you could do this. I used an example that I've seen before, but I think at the end of the day, it matters more what your users find more useful. Um, the biggest thing as the participant who mentioned there is to make sure that the associations are there programmatically so that the user has access to it when they get to the field itself. But as for where exactly it should go, I would definitely say user test with your users and see which one makes more sense for them.
Very good. Thank you for that one. Here's another one that was asked and also answered. I'll read both. Will the updated DOM be available to speech to text, i.e. Dragon? Many SPAs don't make updates available to speech to text. Maybe the accessibility tree isn't updating. The answer that was provided is ref.current.focus.
So for this, it kind of depends on what you are referring to in relation to updating the DOM. So some browsers might have more delays when they're updating the accessibility tree. Ideally, whenever you update something in React and it updates the DOM, it's also updating the accessibility tree as well. If it's not, that's a bug with the browser or with React itself. Ideally, if you can find the use case that produces that, that's a bug. File a bug with those respective places. But there shouldn't be something that prevents this from happening in theory.
All right, excellent. One more question that was asked and also answered. If you're asked to program a card that is a link, the entire card is a link, can you add role equals group to an anchor tag? The answer that was provided, I would think you'd want to keep that link's role as a link, not a group.
Yeah, so if you were to set role equals group on the link, you would override the semantics of the link, and now the semantics for that link are now role equals group, which is probably not what you want. So in that case, I guess it kind of depends on why you're trying to add role equals group. With the link already wrapping all of the contents, if the entire card is a link, I don't really know if role equals group would help you all that much. If you had it where you, I don't know, maybe wanted to make sure that all the different pieces were getting read together. Like I know that on with iOS voiceover, if you have a multi-line link, each one gets read out as its own line. But role equals group actually won't help you there because group semantics aren't conveyed with iOS voiceover. So I would say in this particular case, I would not add role equals group because that could actually be harmful as far as usage.
Right. You are rocking it. Here's one more. Again, this question was asked and partially answered. Does conditional rendering properly update the user if they are using a screen reader? Are ARIA live regions or similar needed for this? The answer that was provided so far is that conditional rendering in React isn't any different from any other JavaScript, which makes DOM elements dynamically appear and disappear. Screen readers won't be aware of that unless either focus is placed on the new element or a live region is used.
Yeah, so that answer is absolutely spot on. And it really depends on the kind of update that you're doing as far as whether you would move focus or you would use an ARIA live region to notify the user about changes. So like if you're changing an entire chunk of the page, you might want to, like if it's not something that needs to have focus moved, you might want to tell the user that a chunk of the page has changed. But it depends on what you're using, the classic "it depends" case, but you'd probably want to make sure that what you're trying to accomplish, like if you're, if you're expanding content and you want the user to go to that new content, or if you're opening a modal, for example, you would want to move focus into the modal. But there are definitely cases where you'd have to figure out, is this something that should move the user's focus, or is this something that they should know about, but they should stay where they are?
All right. Here's another one. This one does not have an answer yet because this group is super active and they're posting questions left and right because they love how you're answering them. Do you have any recommendations for deciding what props we should be defining for our components? For example, one of the slides mentioned using props to enforce passing in values needed for accessibility. But are there good rules of thumb for figuring out the component API design?
That's a good question. And I feel like this is going to really depend on your component and what you're trying to accomplish. My general thought is when there's something that's very specific that I want to support, and I really want people to know that this is a thing I support, I include that in the props definition, even if it's something that's, part of that component. So for example, like type is an attribute that is part of the button component. I might still explicitly add that to the list of props because I know that it's something that you probably should be setting. Similarly, there might be cases where, maybe there's an ARIA attribute that you might want to make use of, or a role that you might want to make use of that you really want people to know exists. And or if you want to control those values more explicitly. So for example, if you wanted to allow role, but you don't want to add certain roles that don't make sense, you could add that prop as one of the props that you accept and then very explicitly define which roles that you would allow.
All right. We have one final question here because we're almost out of time. Do you think that even if the accessibility part is looked at later in the project, will it be possible for the development in React to be smooth?
I'm not sure what smooth means in this context, but I'm guessing the question is more if you already had maybe like a React project that existed and then later you decided that you wanted to make it more accessible, how easy would that be? So I think because the tools that exist with the React ecosystem, there are easier ways to find out that there are errors. It's not foolproof. It's always going to be easy. It's always going to be easier if you thought about accessibility ahead of time. But as far as, I already built this, now I need to figure out what I did wrong. I think there's a lot of tooling available that can really help you with React. Otherwise, there's the standard, you should just test things to make sure that you can figure out what's wrong with it. But that's something that I find to be pretty useful, that React already has, so I don't have to create any of those things myself.
Diane, you're super awesome for bringing your expertise to us, all of us. Thank you for being here. Thank you to our interpreters. Thank you for our producers, our participants. I know that we're coming to the end of AXCON. I love that you all are here. Hopefully you can add a couple more sessions before you leave. Thanks for having us. Bye, everyone.
Thank you.